All right, welcome everybody to week 6, day 3, and we're going to be reviewing loops a little bit because it feels like especially doubly nested and triply nested loops was a problem for the brain of students, right? And it should be. Hack the Mainframe is definitely one of the hardest assignments in this semester, and the reason why it's hard is because there's a triply nested for loop in it with another for loop in there just for good measure. So I've decided to have mercy on you, and I will allow you to turn in Hack the Mainframe by Monday. I will rerun the autograder at 2 o'clock on Monday. However, you cannot turn in my code to me. So if you turn in my own code, the cheat checker will pick it up. I have a similarity detector, and it does things like removing variable names and comments and things like that. So just changing variable names isn't going to help. You have to rewrite it. In fact, my recommendation to you is that if you got a 0 on the Hack the Mainframe assignment, look at how I did it last class and write it from scratch. Just in your own words, just delete all the starter code, just write it from scratch. And you should be able to do it. And it'll look different from mine because it's always going to be different. But don't just like copy and paste my code because then you don't learn anything. I actually want you to learn. I'm weird like that as a professor. I actually care a lot more about my students learning the material than I do about, failing them and filtering out the unworthy and all this kind of stuff, which some professors get off on. I don't. I actually want all of my students to learn the material. So if you are going to do Hack the Mainframe, again, delete the main.cc, write it from scratch. Okay? You understand? And it's not going to count as your last chance. I'm just going to issue this opportunity to everybody. Okay? So even if you got like a 4, redo it. It'll be a good exercise for you over the weekend. You already know the answer. It can't be that hard, right? So, y'all cool with that? Happy? Hack the Mainframe? Understand? If you got a 10, just chill. Yeah, well, there's going to be other stuff, You're getting a new homework assignment today also, which the previous class decided they wanted an entire week to do, which, I don't think it's that hard. The next homework assignment's actually going to be pretty easy. But before we do all that, let's talk about loops. So, I'm just going to review loops really fast. And for int I equals 0, I is less than 5, I plus plus. How many times is this loop going to run? How many times is this loop going to run? 5. That's correct. First time through the loop, I is going to be 0. That's what this means. This part, that part. Why can I not print? Part. That part there runs before the for loop runs. Okay? So it's going to create a variable called I, set it equal to 0. It runs one time at the beginning of the loop. Doesn't run at all since then. Okay? It then immediately checks the conditional here. This is like, you can think of it as saying if. Like there's an if statement there. If I is less than 5, run the loop. Run everything between the curly braces here. And if not, then jump down to here and cout finished, right? Something like that. Okay, so imagine that there is just an if statement here at the very top of every time the loop runs. First thing it does is check to see if I is less than 5. If it is, then it executes everything between the curly boys. If it's false, then it jumps down to the closed curly bracket and keeps running, so it prints finished. And then at the very bottom of the loop, or the top of the loop, depending on your perspective, because it's a circle, but think of it as at the very bottom of every loop. At the end of every loop iteration, it increments I by 1. So the first time through the loop, I is 0. At the very bottom of the loop, I becomes 1, I plus plus, I becomes 1. It then comes up to the top again. If I is less than 5, I is 1, 1 is less than 5, that's true. Then it executes all the code between the curly braces. It prints 1 to the screen. I then increments B2, prints 2, 3, 4, and then I becomes 5. And when I becomes 5, it comes up to the top here. Is 5 less than 5? No. Break. And it comes down here and prints finished. So you need to develop an understanding of what's called tracing a program execution. So like in your head, you've got like this compiler. You've got like a mental compiler and an execution environment. And one of the troubles in being a CSI 40 student is that your mental compiler and your mental executor don't always sync up with what the actual thing's doing. So it's really important when you are a CSI 40 student to see out all of the things. Okay, so before you even like write a for loop or whatever, just start by doing this, like just output I, you know, and just see if it's doing the number of iterations you think it's doing, you know? Especially if you're doing like some weird thing like this, where you're starting at 2 and going to less than 5, like how many times is this gonna run, you know? All right, the first time through the loop it's 2, and then the next time through the loop it's 3, then it's 4, then it's 5. Does it run when it's 5? Wait, is the if statement at the top or the bottom? You know, and so what you do is just run it. Okay, it runs 3 times. Okay, it doesn't run when it's 5. Okay, all right. And then by doing this, you can sync your brain with the computer, right? You can find any bugs in your mental compiler and your mental runtime environment, and you find them by testing them against the machine. And so you just see out the things and just see if the things that see out match what you think it's going to do. And that's a really, really good way of teaching yourself computer science. Just see what the computer does. Right? You know, learn to think like a computer. Have your brain, you know, follow the computer because it's correct. Right? You're probably not going to find any bugs in the compiler in this class. Okay? It's unlikely. So I don't know. I still output all the things. Yeah, me too. Whenever I'm writing code, there's always a chance that I type something in wrong. And I've, you know, if you watch my recordings, I've fat-fingered all sorts of things or copy-pasted without changing. I make mistakes too. It's fine. That's why I see out all the things. And I just run it and just look at it like, okay, that looks right. Okay. I do not trust myself to write perfect code. And I'm a pretty good programmer, you know. I do. You know, in production code, like, you know, I've never had, you know, in any of my web-enabled stuff, I've never had a security breach, you know, because I am extremely paranoid of anything that comes in from a user. That thing gets sanitized to the point that it turns into water. Okay, so we got a singly nested for loop here, and then let's do a doubly nested for loop. So let's put this back to here. So doubly nested for loop, y2, yp, right arrow to right arrow. Let's do this to be 2. See out all the things. I got an I got a J. I'm gonna print them. Before I even do anything with this for loop, I'm just gonna print. Them. Just make sure they match. So how many times is this for loop going to run? Yes. Perfect. Great catch. Thank you. Yes, I put that bug in there intentionally to see if you were paying attention. So how many times is this for loop going to run? Right, and if I had left that in there, by the way, what you would see is this. Right? What's the problem? J is not being incremented. Right? Do you see that? Like when you print out the things, like the bug is, oh yeah, I'm not incrementing J. Why is it only incrementing I and not J? Oh, there you go. Okay, so you guys see that? Like a lot of times I skip over bugs like that because, you know, I catch them first. But when you see out the things, like the bugs become pretty obvious most of the time. And if you know how to use a debugger is a-okay too. It is fine as well. So, how many times is this loop going to run? Question. Answer it. I'm going to keep asking the question too. How many times does this line run? Right here. 5? This line here runs 5 times? 10 times? What do you think? This is why I'm going over nested for loops today. And by the way, don't be embarrassed to guess. So I'm asking you to guess. Feel free to get wrong. Feel free to get it wrong. You're taking this class because you don't know computer science, so feel free to get it wrong. It's fine. I'd be a little mad at you if you're in grad school and you got this wrong. But in CSI 40, that's why we're all here. We're here to learn for loops and nested for loops and stuff like that. So let's trace the execution using our mental compiler. So we run the code. We come in here. We make a variable named I set equal to 0. Is 0 less than 5? Yes. Cool. Move on to the next line. I is 0. Okay. So now 2 times we're going to output this, because this loop here is running twice. So I is 0, so it's going to print I is 0, J is 0, I is 0, J is 1. The inner for loop finishes, comes up to the top here, I is now 1. It then does the inner loop 2 times. I is 1, J is 0, I is 1, J is 1. Comes up to the top. I is now 2, J is 0, J is 1. So it is for every number that I is, this inner loop runs twice. So for every J, for every I, it runs the inner loop twice. So it's going to do a total of 10 outputs. Like that. And you can print it and you can see how it goes. 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1, 3, 0, 3, 1. If we change this to be a 10, how many times is the inner loop going to run? What do you think? 15 times or 50 times? Or 10 times? Or 5 times? 5, 10, 15, or 50. It's going to be one of those 4. Yes, it is 50. Okay? So for each of the 5 values I is, every time I is a different number, it's going to run this inner for loop 10 times. And I is going to be a total of 5 different numbers. Right? So for each value that I has, J will go from 0 to 9. And some people write for loops like this. I don't talk to those people. Technically, yeah, this will run 10 times as well. But we don't write code like that because in C++, C++ really wants you to write code like that, which I'll show you in a second. But let's run this first. So run that. And there you go. So I is 0, J is 1. I is 0, J is 0. I is 0, J is 1. I is 0, J is 2. You guys see the order that this takes place to? Because some students are kind of unclear. Like, okay, when does I increment? When does J increment? When does it do which in what order? Just print it out. You know what I mean? Just print it out. If you're curious what order that will take place in, print it out. I is 0, J is 0. I is 0, J is 1. I is 0, J is 2. I is 0, J is 4. Then it goes 5, right? It goes 9, okay? Then I becomes 0, I becomes 1, J becomes 0. Then it does another 10 J's, and I becomes 2. Okay? So for each value I has, this inner loop runs 10 times. Okay? So that is a nested for loop. And if you do a triply nested for loop, then k equals 0, k is less than 7, k plus plus. How many times is this line going to run now? Do a little math. How many times is that inner line going to run? Yeah, 350 times. That's good. All right, count really fast. Okay, there you go. Oh, I didn't print out K, did I? I need to delete that from my history. There you go. All right. So if you want a word count, by the way, if you pipe the results of a.out into word count by line like that, that's an L. It'll tell you how many lines of output we have. We have 351 lines of output because we got that one there. Okay. So yeah, it's running 350 times. All right. So the reason why we use the half-open code pattern, this thing here, is so that we can work with strings. String s is equal to Bob, right? String s is equal to Bob. Okay. And so you're still mad? That's not size. Okay. And so this is a very common pattern. We should not use int. If we use int, it's going to complain at us. And the reason why it's complaining at us is because s.size returns an unsigned long. So s.size returns a size key, which is an unsigned It's an unsigned 64-bit number. Because a string cannot have a negative length. So it uses an unsigned integer for that. And if you ever compare an assigned and an unsigned integer, it gets mad at you for good reason. It gets mad at you because if you have a negative number for the int, then it turns into an unsigned integer, it underflows up to 4.2 billion, and bad things happen. So whenever you're doing comparisons, you should compare an int with an int, or an unsigned int with an unsigned int. It's hazardous to do a mixing of it. In this case, it'll be fine because the size of s is 3. I is going to go from 0 to 2. It actually will be just fine. But it's good practice to turn off all your warnings. Okay? You should always have 0 errors and 0 warnings in your code at all times. Do not get into the habit of just leaving warnings behind. Like I told the previous class, it's really annoying when you're working on a commercial project, like an official project with real people's real code, and it's got like 1 million errors in it. No, sorry, 1 million warnings in it. 0 errors, 1,000 warnings, right? And there's this one time where I purchased a header file from a person, or my company did technically, and professional code, and it did something we needed, so we sent him some money, and he sent us the source code, and we included it, and now I've got 100 warnings or something in my code because he didn't pay attention to things like this, and now I have to like edit his code, which is annoying, because when you're purchasing 10,000 lines of code, I really don't want to go through it. I just want it to work. And now I've got to go through his source code and fix it because he's got dubious things like this. You know, not even necessarily bugs, but might be bugs someday. And so then I have to go through and fix everything, and that's just a pain, right? So just as a matter of course, you should never allow warnings in your source code. And by default, it's set up to do this. Alias G++. By default, it is set up to do all warnings and extra warnings. Because all warnings is not all warnings. All warnings is just a lot of warnings. And so the dash capital W means warnings. It controls the warning things like this. Like if you want to turn off sign comparison warnings, you can pass that in. And so dash W all means all warnings, but all warnings is not all warnings, just a lot of them. And so what happened was there was a set of warnings that were all turned on together under all. And then over time, they kind of froze that in place. And all the new warnings got put into like a different bucket of warnings called extra warnings. And so if you want to do all warnings, you have to do both wall and wextra. But even that's not all of them, at least not on Clang. Clang has something called W everything, which actually is all warnings, including a lot of stupid stuff that you would never even think about. Clang ++ -W everything .cc, and you can see that it is angry at my header file at read.h. So. These are incompatible with C++ 98. I'm not compiling in C++ 98. No previous prototype found. Like it generates a lot of warnings. I don't use everything. It's mostly pointless. But I do use wall, and I do use extra. Okay. No warnings, no errors. That's what you want to see. He probably didn't even have warnings turned on necessarily, but if he did, then yeah, that's just uncool for you to charge money for software that passes on your warnings to other people. You know what I mean? Then I get to fix it. Okay, so what can we do with Bob here? Well, first thing we do is we just output each letter. And the reason why we do this pattern here, starting at 0 going to less than size, is because it matches exactly with the indices of the string. So index 0 is capital B. Okay. Index 1 is O. Index 2 is lowercase b. Okay. So 0, 1, 2. 2 is less than 3. It's size 3. So we go 0, 1, 2, call it a day. Character I is s.at I. The reason why we do this pattern here, the pattern I always teach you, is because it matches strings and other similar things very exactly. So character 0 is B, character 1 is O, character 2 is B, lowercase b. Okay. So what we're going to do today first is I'm going to run you through doing... It's hot in here. Oh, weird. Doing palindrome testing. Okay. So I think there's a palindrome tester on one of your Xi books. I don't know if you've done it yet, but I'm going to walk you through how I would go about checking to see if something's a palindrome, and then you can compare it with how you would do it. Okay. So a palindrome is, for those of you that don't know, it is a word that is spelled forwards and backwards the same way. Okay. So let's do this. Read. Please enter a word to see if it is a palindrome. Okay. So we're going to read a word, radar, taco cat, whatever, and then we're going to go through it. And what we want to do is see if the first letter and the last letter are the same. If they are, keep going. If they're different, not a palindrome, we can just stop there. Okay, so for it to be a palindrome, all pairs of characters have to be the same. But if any of them are different, not a palindrome, just print it's not a palindrome, and we're done. Okay, so how do we do that? So, all right, well, we already got this. Character I is that, so let's try to print the last character, all right? What is the last character in a string? Can you briefly explain the read function? It's the same as cn. It's cning into a string. Just less typing. Size -1, and we've got an I -1. Okay? Those are both correct, kind of. So character I -1. No, I minus wrong is wrong. That's let's try that actually. Let's see what happens. I set at I -1. And crash, right? And we're crashing because we're trying to access that element, which is not within bounds. That is not between 0 and 2. This is what happens when you have a negative number, right? When you have a negative number with an unsigned integer, it underflows, wraps around, and goes out of bounds. Okay. So what we want is something like size -1, right? So size s dot size -1. Okay. So we're just going to start off printing out all the things, right? That's what we do. So let's see here, radar. Okay, so it's going to print out pairs of, let's put an extra new line in there so it's a little more readable. Okay, so I'm going to type in radar. So it's going to do the first and last. Okay, cool. First and last, cool. Now we're going to do the next letter. Uh-oh. That's correct. That's the next letter, A. But coming back the other way, it should be A also, right? Instead, it's still R. And then we move on to D, the third letter, and it's R here. We're on to the fourth letter, and it's still R, and then the fifth letter is correct, I guess, technically. So what's wrong? Which one of these two is incorrect? The top line or the bottom line? Where's our bug at? And do you notice what I'm doing here? I'm printing the things. I'm not even checking for a palindrome or anything. I'm just printing characters out, just seeing if I'm moving across the string correctly. Yeah, it is the bottom line. Good. The problem is it's not moving, right? So what we want is every time I increases for it to decrease by 1, right? So in the first loop, got the first character and the last character, and then as I goes up to 1, we want this to move down by 1. And if this goes up to 2, this goes down by 2. So that sounds to me like subtraction, okay? And if you didn't come up with s.size -1 minus I, which nobody did on Discord in either class, don't feel bad. It's not something that students come up with off the top of their head the first time, right? This is why I take this approach, right? Because I'm not even, I'm supposed to be doing a palindrome, but I'm not even there yet. I'm not even at the point where I'm actually, having any logic to do a palindrome. A lot of students just try to do it all at once, and then they have like, you know, that thing missing there. And I'll show you that it actually works. And then they don't know why their code doesn't work. Professor, help me. You know, like, it's because you're jumping too far ahead. You have to make sure each step along the way is correct. So if we do radar again, R and R, A and A, D and D, A and A, R and R. Okay, looks like a palindrome to me. Now let's type in something not a palindrome, balloon. Okay, so B, first character, last character, second character, second from the last, L and O, L and L, O and L, O and A and B. Now, is this redundant? What do you think? We're checking to see if B and N is the same, and we're checking to see if B and N is the same. We're checking to see if A and O is the same, we're checking to see if A and O is the same. We're checking to see if L and O is the same, we're checking to see if O and L is the same. Is that redundant? Do we need to do those last 3 checks? Yeah, I think we can. It is redundant. So the question is, do we round up or do we round down? And this is another off by 1, an area where an off by 1 can come in. Okay, we've got 7 letters here. Do we do 3 comparisons or do we do 4? It is really good for testing, sure. But now that I have seen this and I know that it's working, I'm going to cut off the second half. Okay, but do I round up or do I round down? We got 7 letters here. Do I test 3 pairs of letters or do I test 4 pairs of letters? What is the 4th pair of letter? I said letter intentionally. It's that one. It's actually testing the middle letter against itself. Do I need to do that? Do I ever need to check to see if a character is equal to itself? What do you think? Or is that redundant? Is that redundant? I don't think so. I think characters are reflexive, and so L is always going to be equal to L. So I don't think we actually need to do the 4th comparison. I think we can just do 3 comparisons. And if all 3 of these are the same, it's a palindrome. If any of them are different, not a palindrome. And notice how I said that. It's not a symmetrical problem, right? It's not like it's evenly balanced. All of them have to be, all pairs have to be the same to be a palindrome. If any of them are not, it's not a palindrome. It's a bit asymmetrical. And that's going to be reflected in the code. So first of all, let's get rid of the redundancies. So I'm going to do s.size divided by 2. So that will round down because it's integer division. Right. So now if I run this again and type in balloon, if I run it again and type in balloon, then you see it's only doing 3 comparisons. B and N, A and O, L and O. The middle one we know is always going to be the same. We don't need to do it. Okay. Looks like DoorDash just arrived. Cool, whatever. Actually, I'll be right back. I don't want flies to eat it. Okay. Yeah, I got Did Chico's. Show us the food. Not during class. Don't eat in the computer lab. This is my computer lab. We see the other half of the string with the, yeah, exactly. So B matches N. And that little thing there, that -1 there, that is a source of a lot of bugs. So a lot of people think s.size is the last character. No. If you've got 6 letters in your string, the size is 6. But the last letter is in index 5 because they go from 0 to 5, not 6. So when you're counting backwards, you always have to knock a 1 off. Okay? Size -1. Okay, so we got all of our pairs set up now. So, okay, let's move on to actually solving it. So, if they're the same, I'm just going to say print out, this is the same as this. Okay. So if they're the same, I'm going to print out they're the same, and otherwise I'm going to print out They are not the same. So you see what I did there? I just kept all my code. Yes, needs one more parentheses there. Okay, so radar. Character R is the same as. Sorry, I need to clean that up a little bit. Character R is the same as. YY P is not the same. Okay. Alright, so we're gonna type in radar. R is R, A is A. Cool. Let's type in balloon. B is not the same. A is not the same. L is not the same. All right. Raccoon. R is the same. A is not. Okay. So our comparisons are now working. And you notice I'm still just printing out all the things. Once I know my indices work right, then I go into seeing if my comparisons work right. And this, I'm still not saying if something's a palindrome or not. Right? Do you see that? Is there a way to learn what the errors mean? Which errors? Like compiler errors? Warning errors? I asked Bjarne Strustrup, the guy who wrote C++, that very question. And he said the best way is just to ask your professor. Because some errors in C++ are easy to understand and some are not. And if you get something you don't understand, just ask your professor. The compiler errors, yeah. So like if you leave off a parentheses there, then it says expected parentheses. So, and by the way, these error messages are so much nicer than they used to be. Right now, it's showing you, here's the starting parentheses. Here's where we expect it to be. Here's the open curly brace. There needs to be, look, there needs to be a parentheses right there. Like it's actually telling you, right there, you need to put a parentheses in. And Mr. Bell, do you remember when you took my class, like a few years ago? Like, like this is actually like, they've been getting better at it. You know, like I went to CPPCon in 2016 and did a poster in part on how bad error messages are in compilers. And the people that make the compilers came by and kind of went, yeah, okay, that's fair. G++, do I have G++7 installed in here and G++8? Nah, I don't have the old versions. But yeah, it didn't have colors. It didn't tell you where these things were. It just gave these really obscure error messages. So it's actually nicer now than it used to be. Okay, so yeah, so I'm not even testing for palindromes yet. I'm not. There's no. I'm nowhere in here am I saying is it a palindrome? Is it not a palindrome? I'm still just scouting all the things. So do you see how I'm building this? Like a little bit at a time, a little bit at a time, because I'm now happy that I'm now confident this is actually checking the right pairs of characters as it goes down the line, and I'm not doing wasteful comparisons. Okay. Half the error messages were something's wrong on line 23. Yeah, and it used a lot of jargon and things like that that didn't mean anything to new programmers. Do you guys see this? Like, seriously, this is actually really important because this is how you have to approach writing code. So many students just like get stuck, you know, because they try to write the whole palindrome thing. It doesn't work. What's the problem? Is it your index isn't right? Is it the comparisons aren't right? You know, there's so many different things that it could be wrong. You have to be able to write it so that there's only like one line at a time that could be wrong. You know, and then you can just laser focus right on that line. Okay, that line's wrong. You know. Nothing? No comments on Discord? Okay. I'm just telling you, this is really important. Okay, let's do it then. Let's do some palindrome checking. So, I can comment this out. I might bring it back later, but yeah, so if any of the characters are not right, then I could just be all, yo, palindrome not detected, boom. Okay. And I could just quit the program at this point. Okay. And so a lot of students want it to be symmetrical, and so they will do this instead. They will do this also, I should say. It's a palindrome. Okay. Does this look correct to you guys? Write, test, cry, debug. Yeah, except it should be like, oh, right, I forgot a parentheses. right? Because there's only one line the problem could be on. No, this isn't correct. Why? What case will this not work on? Let's test it. Let's see if this works. Radar. Palindrome detected. Taco cat. Palindrome detected. Bookshelf. Palindrome. It's correct. It's 100% correct. What are you guys talking about? It worked for every test case. All three of them. Let's ship it. What's the problem? Can you come up with a test case that will reveal the bug in my code? You want to do that? Okay. That. Palindrome detected. Oops. It's not a palindrome. Our code's wrong. Why? Because it is... Look at what it's doing. If the first character matches, it's done. Okay. The first and last characters match. Ship it. It's a palindrome. It's not. You can't do that. You can't just say palindrome detected after the first pair of letters. You gotta look at all of them. So, there's a couple different ways you can do this. Easiest way is just to slap this down here. So, if we get a match, do nothing. If we don't get a match, print palindrome not detected. Because if we get any of them, if any of them are not palindromes, that's it. It's not a palindrome. Print palindrome not detected. Quit. Okay. All right. So now, it works. Okay. So radar is a palindrome. That is not a palindrome. Taco cat is a palindrome. Amana planet canal pana is a palindrome. Long palindrome. Okay. So, yeah. And what you saw there, though, is something that probably half of all my students would try, right? When they're doing a for loop. But you have to think about it. You have to think real carefully. Like, should I bail out? You know? Or do I have to keep going? And these are the kinds of... And test it, you know? That's the thing. Like, if you're not really sure, just test it and find out if your code is awful or not. I mean, like, you know, just see if it works. And you have to think about, like, all the different test cases and things like that. So, yeah, this is correct code. One problem, though, is that this code won't work if I need to, like, keep going. And if I want to have code down here, if I don't detect a palindrome, it just quits. And so I kind of want to do this instead, right? I just want to... All right, it's not a palindrome, and stop the loop. We don't need to go any further, right? But the trouble is, what's going to happen if I do this? What's the problem with this? So I don't want to just quit the program, you know. I want to keep going. Was it a palindrome? Not a palindrome? Print it out. Keep going. What's the problem? Yeah, it'll still output palindrome detected. So if I type in that, palindrome not detected, palindrome detected. Uh-oh. So, how can I solve this? How can I remember, after the for loop is done, that a palindrome was not detected? What do you need to remember stuff in C++? What is our tool for remembering things? Variables, very good. So we need to have a variable, bool matched. And in the previous class, they said set it to false. And then if you find something, set it to true. And then at the end here, if matched, palindrome detected, else palindrome not detected. What do you think? Is this correct? If any of them match, is it a palindrome? Or do all of them have to match? Because right now it's saying if any of them match, it's a palindrome, right? So as we're going through, if any of them match is going to be true, and it's going to print palindrome detected. Yeah, this is wrong. So what you need to do instead is the opposite. Assume that it is true, and then if you ever find somebody that is not a match, set it to false. Because if any of them are false, then not a palindrome, quit. This is correct code. And you might be like, but wait, this if statement is completely empty. Yep, it is. And it's fine. You can actually write code like this. You'll probably get a weird look. Probably the better way of doing this is just to turn that into a not equals and do that. Simplify. So if any of them don't match, palindrome not detected, radar radar getting extra tests in there, palindrome detected, taco, cat, palindrome detected, happy, T, a lowercase t, so uppercase and lowercase do matter. Race car. It works. This is correct code. So what we're saying in plain English is we're going to assume that we have a match, and as we go through, if we find any pair of characters that don't match, set match to false and quit the loop. We don't technically need the break, but there's no reason to keep going past that point. Because once you've found that it's not a palindrome, it's not going to be a palindrome. Can't come back from it. Why use bool? You could do an integer, and I've seen students do it that way. So the integer counts how many matches you have. So every time you get a match, you increment it by 1, and then if you've got 6 matches for 6 pairs, it's a palindrome, but you don't need to. If something's a palindrome, can be held just true and false. If any of them don't match, that's it. We don't actually care how many matched, right? There's no benefit to us knowing 2 pairs matched or 3 pairs matched. Nah, it's not a palindrome. That's it. Okay. So that is that. Okay. So let's move on to your next homework assignment. So your next homework assignment is going to be much easier than Hack the Mainframe. It is called Mandarin. So let's become Mitchell 4. And for this assignment, you are going to be translating numbers into Chinese. Okay? So pretty easy. Chinese is a very easy language to learn. It's a very easy language to translate. It's not like Japanese. Japanese has irregular everythings. Days of the month are irregular. Counting is irregular. Like just numbers are irregular. They have different numbering systems. The language itself is a pastiche of Chinese and native Japanese. And so for every character, there's 2 different pronunciations, sometimes more, sometimes less. Chinese, easy. My first day of Japanese class, she said, if you want to have an easy A, go take Mandarin. And everyone laughed, like, ha ha ha. No, actually Japanese is really hard. Mandarin is really easy. It's legitimately the easiest language I've ever learned. And I've studied, I guess, 5 languages at this point. And again, I'm not bragging about it. I'm not good at any of them. But I've, taken classes on them because it interests me, because I suck at it. I like taking classes on things I'm terrible at, like art. I'm not good at art, so I try to push myself on art because I'm not good at it. Okay. So Mandarin, though, is easy, and you're going to appreciate this. It's very simple. So what you're going to do is you're going to do a for loop. So literally, the user is going to input what's the starting number, what's the ending number, what's the step size. Those are the 3 parts of a for loop. Boop, boop, boop. Okay. And so, for example, count from 1 to 10 by 2s. And so it's going to start at 1, go to 3, go to 5, go to 7, go to 9, and then stop, because the next one's 11. 11's past 10. Don't. You're done. Okay? And then for each number, you're going to print the number, and then you're going to print that number written in pinyin, which is the romanization of Zhongwen, or Guoyu, Mandarin. Right? And so the good news is it's very easy to translate. Okay? Chinese is the easiest language that I've ever learned, and I'm not just saying that. It really is. In English, we got numbers like 12 and 13 and 17, 21 with a hyphen. When you're counting from 1 to 100, there are special cases, right? In French, there's 89, right? So 420s and 9. So French is pretty regular. The teens are irregular, but like the 20s and 30s and 40s, 21, 22, 23, 24. You know, the 21, 20 and 1 is a little bit weird, but those are all normal until you get to 80, which is 420s. So you don't say 80, you say 420s. Unless you're in Belgium, in which case you say 80. 90, you don't say 90, you say 420s and 10. It's ridiculous from a language design standpoint. So the Belgians will just say 90, but in France, you say 92 is 80, 420s and 12. It's ridiculous. Yeah, 7 years ago. It's exactly right. English to Chinese is not hard. It's really not hard. Chinese grammar is identical to English grammar by and large. Like in English, if you want to describe the large soft blue ball, there's a certain implicit order those adjectives have to go into. You can't say a blue soft big ball. That just sounds weird. A big soft blue ball? What? Huh? A ball soft blue big? No. There's a order that we all know that we can't enunciate, that the adjectives have to go in, and it's exactly the same in Chinese. It's crazy because they're completely different language branches, and they just worked out the same way. Chinese and Japanese have very different grammar. Korean and Japanese are very similar. Korean and Japanese are almost identical languages with just different pronunciation. But Chinese and Japanese have very different grammar, and fortunately, Chinese grammar is like English. Japanese grammar puts the verb at the end. So in Japanese, you say "Watashi wa tomodachi to mise ni aberu." So I, with my friend, to the store walk, right? Whereas in Chinese, you say "我学习中文." I study Chinese, right? It's literally I study Chinese. 我学习中文. I study Chinese. And Chinese has no conjugations. It has no irregular verbs. It has no tenses. Like, you know, the worst part of French was just memorizing all the different irregular verbs. You get tables and tables of irregular verbs, and you have to memorize this verb in this tense, third person, first person, whatever. Mandarin has none of that. I go store buy Coke. I tomorrow go store buy Coke. I yesterday go store buy Coke. I now go store buy Coke. There is no conjugation. There is no tenses. It's really nice. It's so easy to learn. It really is. The only thing that terrifies people are the tones, and the tones you can learn in about 2 weeks. And so each one of these, and you don't have to do tones for this assignment, by the way. But every character in Chinese is one of 4 different tones, or the neutral tone, depending. So, for example, mother is mama. Mama. First one is first tone, which is a high, even pitch. The second one's neutral tone. Mama. And then to yell at somebody is ma. Dropping tone, fourth tone. To scold somebody is ma. You know. And then you've got horse and you've got marijuana, which are ma, ma. So high tone, rising tone, dropping and lowering tone are the 4 tones in Mandarin. And if you get them wrong, you're going to talk about, you know, sleeping with somebody's marijuana. And that's just embarrassing. Or even worse, sleeping with somebody's horse. You know, you just don't want to do that when you're on an Xbox live chat, you know. It's just embarrassing to yourself. So you got to get the tones right. You know, that takes about 2 weeks. But beyond that, the only thing that you need to learn is the characters. That, you know, every language has vocab, but basically the characters look really scary. But all the characters come from other characters mostly. You know, there's some really basic fundamental characters like a square. You know, what does it mean? An enclosure. And all of these things are like really straightforward. Like Zhong is middle. Like Zhongwen is the language of the middle country, China. Zhongguo is China, middle country, right? And so why is it middle? Well, it's a line through the middle of something, right? Fire, Huo, looks like English. Let's see, that's fire. Yeah. So the character for fire looks like a fire. Yeah. And so for the simplest characters, like they're like pretty Like, yeah, okay, that's fire. You know, and then the more complicated characters, like, look, it's fire over fire. What do you think that, if you guys just had to take a guess, what do you think fire over fire means? If you just had to guess. Wild guess. Fighting? Oh, that's a good one. Inflammation or infection. Okay. What about three fires? You know, shining, glowing. You guys kind of get what I'm saying here? Here's a person. That's the radical meaning person. That's a person next to a fire. And so the meaning of this is a partner, somebody who shares a fire with you. You know, and so when you start learning Chinese, like the first 100 or so characters just seem very random and sort of arbitrary and stuff like that. But then you start learning there's like a pattern to like everything, right? And so you can see there's a genealogy. These characters come from this one, and then these come from this one. So for example, this one, that's the language radical. And then, okay, let's see what this one means. This is hui, ashes, right? Okay, makes sense. Cool. So it's fire that can be handled in your right hand. Okay, yeah, that's the character for right hand. Now written as left hand, gotcha. Yeah, and then fire that can be held in your hand is an ash. Cool, makes sense. And then this one is language. That's language, and that's the character for ashes. So, words that are neither black nor white. Oh, interesting. Oh, yeah, that's phonetic. Yeah, so most Chinese characters are composed of two halves. There's a left half and a right half, sometimes a top half and a bottom half, like this one, which is black. So window altered by fire, right? Black. So usually there's two halves, and one of them carries meaning, and the other one carries pronunciation. So even if you've never seen this character before, if you know how this one's pronounced, which is hui, you could guess, okay, it's pronounced hui, and it has something to do with language. I don't know exactly what it means, but it's pronounced hui and has something to do with language. And so this means funny. Okay? So I didn't know that. I've never seen that before. But if I knew what that is, and I told you, like, that has something to do with language. I don't know what it means, but it has something to do with language. And so you can kind of guess. And so when you kind of get into it, so that here's language next to infection. Okay? So language next to infection. The infection is a phonetic. So it's yan, but this one's pronounced tan, because the pronunciations change over the years too. So to discuss with somebody, see, language radical has something to do with language. It has to do chatting or having a good rapport. So it has nothing to do with infection. The infection side is the pronunciation guide. It's pronounced like this one, but it is something to do, the meaning is with conversation or language. Okay. So, yeah. So Chinese is actually, like, if you want an easy language, really, and it's really impressive too. Like, people are like, oh, how could you know Chinese? And it's like, I took a class. You know? Firefighter, yeah, it could be. Yeah, and people just go, what? You know, so it's you know, I bumped into some Chinese people in parking lot in Vegas. I'm like, Doubly. And they're like, what? You know, and I said, oh, you know, everyone in America speaks Mandarin. I say in Mandarin to her and then walk off. Yeah, it's fun. So, 在中国多人多人会说中文, you know. It's just super fun. Okay, so here are the words in Mandarin that you're going to have to translate. Okay, and you're like, but wait, only 1 through 10? No, you're going to have to translate all the numbers up through 99,999. And if this was other languages, that would be tricky. You've placed high expectations upon you? Nah. Because here's how Chinese works. This is an example of how easy Chinese is. What is 55 in Chinese? 5, 10, 5. What is 505? 505. What is 555? 5 hundreds, 5 tens, 5 fives. 500, 5, 10, 5, 5. That's it. So when you know the numbers from 1 to 10, you can do any number from 1 to 99. Then you have to learn what the number for 100 is, 5. And then you can do all the numbers up to 999. Like, there's no irregulars, there's no 12, 13, 4, nope. No 21, nope. In Japanese, you have shichi or nana for 7. Nope. It's just always chi, you know. What's 77? Chi sure chi. 7, 10, 7. That's it. What's 1,234? 1,200, 3 tens, 4. That's it. So what I recommend is you write a function. So you write a function that takes in a number, 1 through 9, basically, and returns the Chinese word back out. And here is the translation right here. Okay. So 1 to 10 in Chinese and Mandarin is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. You don't have to do the tones. Don't worry about it. There's a special case for 0, which is ling. Okay. Ling will appear nowhere else. It's only when it's exactly 0. So it's like if the number is 10, you don't say sure ling. That would be weird. 10, 0. No, it's just 10. Right? So if the number is 40, it's 4 tens. It's not 4, 10, 0. Okay? You guys understand? So make a function and just translate 1 digit to Chinese, and then you're basically almost there. How would you split 82 into 2 digits? How would you find out the first digit and the second digit? Like if you had to translate 82 into Mandarin, how do you get the 8 and how do you get the 2? How do you do that in C++? There's a couple different ways you can do it. How would you do it if you had 82? Funny, Ricardo. So, nice. Very nice. Yeah, division. Division by 10 gives you the 8. 82 divided by 10 is 8. 82 modulus 10 is 2. So division by 10, that's the 8. Modulus by 10, that's the 2. If you have 882 divided by 100, that gives you the 8, right? So, yeah. So that splitting into digits, you've done that before. And then just translate each one of them. So get the hundreds digit. And if the hundreds digit is non-zero, if it's a 2, 2 by 2 hundreds. And then if the tens digit's not 0, it's 5. Woo, sure. If the ones digit's not 0, it's 9. Chill. That's it. You got a week to do this. Because the previous class voted for a week. I don't think it's a week. This is actually a much easier assignment than hack the mainframe because it's a single for loop. You write one for loop to count from one number to another, and then you just have a function that translates an int into a string containing a Chinese translation of it. Okay? Did you tell us what Mandarin for 100 is? Yeah. So Mandarin for 100 is bai. And then you got Qin for 1,000 and Wan for 10,000. You don't have to do things bigger than Wan. Why? Because I don't know them. I could look it up, but that's as high as I learned, so that's, and so this is a good exercise for you. It's targeted right at your competency level right now as far as where you should be in the material. It's got variables, it's got if statements, you got a special case 0, for example. 0 is a special deal. It breaks the pattern. Probably because ling was added later, you do hear ling in like phone numbers and things like that. Like you'll hear like ling, 440, things like that. But in like 50, there's no ling anywhere else except when it's exactly 0. So you have to have an if statement in there to special case that. And you got some algebra in there. You got divisions and moduluses and things like that. So you can get the tens digit and the ones digit and the hundreds digit separated out. You got a for loop. You got a function call to translate a digit into a string. Yeah. So just integrating all these things together is going to be a good exercise for you. Because, like I said, learning C++ is like learning a foreign language, right? So you need to just keep practicing it. You need to keep doing it over and over again. And, yeah. I mean, it's ironic that this is for a foreign language, but, same idea. Like I learned these numbers in my Mandarin class, 2004, and then I went up to Del Norte for work for a week, And because I was missing class, I was just sitting there practicing my Mandarin. And like I told the previous class, I was waiting outside for the Del Norte aquarium to open. And I wanted to see the old man octopus, which was something that people in Del Norte that I was working with had told me about. It's like this 80-year-old octopus. And he was famous for like sneaking out of his aquarium. He would like lift the lid on his aquarium and sneak out and go over to the other aquarium tanks and like lift the lid up and like fish out of it and eat it like Gollum and then go back into his tank. And fish would just go missing. And he's just sitting there like, I don't know what are you talking about? Never seen that fish before in my life. And it was a mystery for years. Like fish would just vanish. And they're like, how did it get out? Did it teleport? You know, what's happening to our fish? And the old man octopus would just sit there like, I don't know. And then one night they find it like sneaking like a ninja, you know. Flashlight. And he'd always go back to his tank. Like he liked his tank. But he also liked eating fish. So he would go around and take a look at what was on the menu tonight and go snatch a fish, and he didn't go back into his tank. Is old man? I don't know. That's a good question. Del Norte Aquarium. I saw it. Yeah. It was an old, grumpy-looking octopus. Let me tell you. Del Norte, California. It's right on the border of Oregon. It's a nice area to visit, by the way. It's most famous for its prison and for its airport being terrifying, by the way. Ocean World, that's it. Its airport was designed to be deliberately hard to land in because they wanted to train aviators in World War II to do crosswind landings. And so the airport is on next to the ocean, so there's always this breeze blowing this way. So you're landing with a breeze blowing this way. So the airplanes have to... it's a little disconcerting. The airplane actually does this. It actually points... It rotates its landing gear to face forward, but it points into the wind. And so you're coming in sideways into the landing. And so I'm sitting there looking out my side window, looking down the landing strip, having it coming at me. And I'm like... And we land, and the wheels are actually pointing the right way. And then after you land, then the plane rotates on its wheels and levels up. And damn, that was scary. Is learn more... I'll have to look up if Old Man Octopus is still alive. That was a cool dude. Old Man Octopus. Angriest Octopus. No, that's not it. All right. Okay. So, there you go. That's Mandarin. You got a week. All right. So, let's pull up a presentation and run through this real fast. Strings hold multiple characters. You know that already. Did I not save that? I thought I fixed all these things. I keep fixing these smart quotes over and over again. And PowerPoint is just super insistent on putting them back. I don't know. I don't tell you. So plus operator works on strings. I think we talked about this before, but I'm going to reiterate it. So if you say A is equal to A plus B, A is equal to hello, B is equal to goodbye, then it concatenates the strings together. So A becomes hello, goodbye. No space in between, because there's no spaces here. But minus doesn't work, multiply doesn't work, divide doesn't work, just plus. Okay. In other languages, you can multiply a string. So if you have hello and you multiply it by 4, you get hello, 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 hello. Not in C++. Yeah, so concatenation, very useful. Not equals works, double equals works, less than or equals works. All the comparison operations are defined on strings. Let's see. You can get... I don't know why you are here. Get rid of you. So you can get the size of the string by calling .size on it with parentheses because it's a function. And you can get the individual letters using .at. So no fighting in the war room is a Dr. Strangelove reference, and this will give you which letter. If I say print out a.at 1, is it going to print out the N or is it going to print out the O? Don't pay any attention to the comment there. Oh, very good. Okay. Index 0 is N, index 1 is O. Okay. So S.at1 is the second character, not the first character. Oh. Got more. I keep hitting save. I don't know what's going on. All right, so string A is equal to hello. So this will print the first time through the loop, I is 0, so it's going to print the capital H. Second time through the loop, I is 1, so it prints the E, and it does an enter in between each one, so it's going to print H, enter, E, enter, L, enter. So it's going to print hello vertically. All right, so one other thing we should talk about. You do have a Zybooks up. I don't know if you saw that on there, but there is a Zybooks up right now. It's going to be chapter 2 on Zybooks. There's also these things called unsigned integers. So an unsigned integer is an integer that can't hold negative numbers. So rather than going from negative 2 billion to positive 2 billion, an unsigned integer holds numbers from 0 to 4 billion and change. And so 3 billion could be put into an unsigned integer, but not a regular integer. And negative 1 can't. If you try putting negative 1 in there, it underflows and it becomes 4.2 billion and change. Okay. But, if you need to store 3 billion into an integer, unsigned integer, don't do this. Don't do this. Because it makes me very uncomfortable when I'm getting close to the boundary of an integer, because it can overflow. And it can overflow even like without you realizing it. Like if you're if you have a temporary variable and you like multiply by 2 and divide by 2, you multiply by 2, it overflows, and then it's less than something, and things just get really dicey when you're up near the boundary of an integer. There's a lot of ways bugs can sneak in. So rather than using an unsigned integer, I would do a unsigned long. Right, so bullet point. So I would use an unsigned long for x instead. So if you want to see how many numbers an integer can hold, an integer is 32 bits on our system. 2 to the 32 power is 4.2 billion and change. If you have a 64-bit integer, which is what a long is, unsigned long is a 64-bit number, 2 to the 64th power is significantly bigger, right? So rather than 4 billion, thousands, millions, billions, rather than 4 billion, it can hold trillions, quadrillions, whatever is after quadrillion, pentillion, I don't know. It holds a really big number. So an unsigned long is 8 bytes instead of 4 bytes. So it's an extra 4 bytes of RAM. So if you can spare 4 bytes of RAM, I would use the unsigned long. Okay? I've got 32 gigs of RAM on my computer. I'm pretty sure I can spare an extra 4 bytes on my system with 32 billion bytes of RAM. So if you need the extra range, use an unsigned or long, or just, instead of an int, you can use a long. Okay. All right. So there's a library called cctype that has different functions that work on Ascii characters. Ascii characters are held in chars, and vim name.cc. Where am I? I've posted the Palindrome code, by the way, in public. So if you want a copy of the code, copy /public/palindrome.cc to your current directory. So if you want to copy that so you can stare at it, look at it with admiration and respect, you can copy it to your... I just put it on Discord too. You can get a copy of that. Okay, so there's a couple tricky bits with chars, because chars are actually integers. They're 8-bit integers. Since they're 8 bits, they can hold 256 possible values, but the Ascii table only goes from 0 to 127. So it's actually a 7-bit encoding scheme. The 8th bit isn't used at all. And so that's where Unicode UTF-8 comes in. UTF-8 says if that high bit is set, then it's a Unicode character. If it's not set, it's ASCII, and I understand it anyway. So Unicode UTF-8, at least, is backwards compatible with ASCII, because ASCII is the most common encoding scheme in the world. So if we do this, chars equals A, cout C, is this going to print the ASCII code for C, or is it going to print A? The ASCII code for C is what, 65? Man, ASCII, if you want to look up the ASCII table, A is 65. Okay? So is this going to print 65 to the screen, or is it going to print A? What do you think? Put your guesses in now. Yes, it will print A. And the reason why it will print A is because even though this is an integer, C++ is like, it knows what a char is. And it knows that a char is usually supposed to be an ASCII encoded integer. So while you can use this as an 8-bit number, you have to be careful when you see out them because it'll ASCII encode them. So if you want this to be, if you want to see the ASCII code, you do this. Convert it to an integer, it'll print the ASCII code. Or if you want to be like super proper and correct, you can do the casting that way instead. It's more typing for no benefit, but there you go. So if we do that, then it will print 65 instead of A. Okay. But by default, it prints A. Okay, here's a fun trivia. What is that going to print? What is A plus 1? It's not going to be 65. A is 65. So if you think it's going to print the ASCII code, it's going to be 66. All right. So B, okay. Survey says 66. What? What happened there? What happened? Remember the rules. If you ever mix two types for arithmetic that are of different types, it goes to whichever one is wider. Wider means more bits. An integer is 32 bits wide. A char is 8 bits wide. So it converts the char to an integer and returns an integer. And when you print an integer, you get a number. Okay? So if you wanted to print this using ASCII encoding, then you can cast it back into a char. So that will convert 66 integer. It narrows it. It does what's called a narrowing conversion, which throws away the top 24 bits and puts that 32-bit number into an 8-bit number, and then outputs it as an ASCII. So if you do this, we get B. All right. Trivia question number 2. What is this going to print? What is this going to print? Let's do it. Make it a little harder. Place your bets now. Will it compile? Good question. Yes. So what we're doing here, let's work through the logic. Anytime you have a single quote thing, by the way, you can't put Unicode in here. A very common mistake students make is they try like sticking like a, diamond hands or something inside of a single quote character. You cannot do that. Single quote is used for ASCII. If you're ever doing anything that's not ASCII, which is like the basic character set, don't do it. Use double quotes instead. C++ does handle Unicode, but you have to put it into double quotes for it to work. So what's going on here? So A is 65. Okay. So it adds 4 to it, and this returns an integer. So this is going to be integer value 69. Nice. Now, that's going to get stuffed back into a char, character, whatever, however you pronounce it. Okay. So this is going to create an integer, and then it's going to put it back into a char. It's going to narrow. It's going to do a narrowing conversion automatically. And so when you output this, C is not it can't ever be 69 because it's a char. It would print the ASCII code instead. So the result of this expression here is 69. But once you stuff it back into a char, it narrows right there. It's a char again. This is a char. It will print E. Okay. So that prints E. All right. There are various functions you can do with chars. Again, ASCII code. And again, if you want to look at the ASCII table, one more. Right, char C is equal to capital A plus 32. What is that going to print? Tim has it correct. It is going to print lowercase a. So the lowercase letters are 32 points above the uppercase letters. So this uppercase, if you have an uppercase letter and you add 32 to it, you get the lowercase version of it. And if you ever want to look at the ASCII table, 65 is A, and 97, 32 bits above it is lowercase a. Unfortunately, the lower 32 bits of ASCII are almost all useless. They're all they were useful 50 years ago maybe. They're not useful now. There is no use for data link escape or device control 1. None of these are used. In the first 32 bits, they're all control characters mostly. The only ones that are still used are null. Null is the empty string, and it's used to terminate a string. We're going to learn C-style strings in future semesters. You really don't need to know them for this semester. You do need to know them eventually because, like, the Linux kernel takes C-style strings, which is an array of characters with a null at the end. You don't need to know that for this class. The bell character, if you want to beep, cout \A, and it'll beep your terminal. \T will print a tab character. \N hits return. Those are the only ones that are used in the first 32 entries. And to me, I consider it a real shame because the ASCII table is not very big, right? There's a lot of stuff that we would want to print to the screen that didn't make it into ASCII, like accents, right? If you want to do an accent E or something like that, that would be nice. It looks like there's some room here that we can, but you can't change it. It's a standard, right? So that's what Unicode's for. Unicode has essentially unlimited amounts of character points within it, which you can use to do ninja cats and things like that, and you can't really run out because you've got billions of possible Unicode characters. Okay, so there are character functions that work on ASCII characters, not Unicode, just ASCII. 2 upper and 2 lower, they take in a character and they return an uppercase version of the character. So if you pass in a lowercase a, it gives you uppercase a. If you pass in question mark, it gives you question mark. So if it's not a alpha, then it doesn't do anything. It just returns the same thing. If it is a lowercase alpha, it returns the uppercase version. Otherwise, it just returns the same thing. 2 lower does the opposite. The lowercase is a letter. Unfortunately, there is no 2 upper or 2 lower on strings. That would be really nice. It doesn't exist. So you cannot 2 upper a string. You have to write the for loop yourself to do that. And then there's a bunch of is functions that are part of the CC type library that is very useful for identifying which part of the ASCII code table the character is on. So is this a letter? Is it a number? Is it a digit, right? Like the letter 5, right? Not integer 5. Is it the letter 5? ASCII code, whatever. And so is upper tells you if a character is an uppercase letter. Is lower tells you if it's a lowercase character. Is alpha tells you if it's an A through Z, capital A through Z, lowercase a through Z. Is digit tells you if it's letters 0 through 9. Is alnum is either an alpha or a digit. So A through Z, 0 through 9, true or false. Is space tells you if it is a space character, which is either a space or a tab or a new line. Is graph tells you if it's a printable character like asterisk or F or space or 5. Pretty much everything is a graph except for control characters. And then is control character tells you if it's a control character or not, like null or device in the file control 7, whatever worthless things they populated the table with there. It's there for historical reasons. It made sense once upon a time. Doesn't make sense now, but whatever. What's done's done. What's won is won. What is lost and gone forever. So, it is now lab time. I would like for you, in the span of the next 22 minutes, to make a game. A full game. Alright? This is what I want you to do. At 3:50, I am going to ask you to screenshot it and post it into chat so we can see how much you did. Even if you did nothing, I want to see. Even if all you got was hello world, I want to see what you did. Okay? In real life, I can walk around and see what people are doing. Online, I don't have that same connection. So I'd like for all of you to screenshot your work at 3:50 and send it in. Then I'm going to code it up from scratch. All right. So what it is, it's a treasure hunt game. You're on a field of size 5 by 5. Somewhere on the field is a buried treasure, and you can randomly place the treasure somewhere on the world. And the user starts at 0, 0, and they can walk north, south, east, or west. Either lowercase or uppercase letters works fine. N, W, E, or S. Uppercase, lowercase, doesn't matter. And so the user is going to walk around, and if they walk upon the spot where the buried treasure is, they win. If they make 10 moves without finding the buried treasure, then they lose. Okay? Go. You're making Skyrim? You can do that. 22 minutes. Go. 20 minutes now. Go. Alright, so let me show you how I do it. So I'm going to code it up from scratch, and let's do this. Vim main.cc. Okay, so first thing I'm going to do is I'm going to make a location for the player. X equal to 0, y is equal to 0. That seems like I got a moth in here? I got a moth in here. Terrible. X equals 0, y equals 0, and we also are probably going to need a location for the treasure. So I'm going to say integer treasure x is equal to rand modulus 5, and the treasure y location is also going to be equal to rand modulus 5, and I'm just going to see out treasure x and treasure y because when I'm running the code, I don't want to have to actually find it. 3-1, cool. 3-1, cool. Oh, wait, cool. Wait, no, wait. It's always the same. What do I need to do? What do I need to do? This is why you see out all the things. What do you need to do? srand. srand time 0. And this is good for non-mission critical stuff. There is better ways of doing random numbers than this. So now when we run it, as long as we don't run it multiple times per second, it'll be fine. Because this returns seconds since the beginning of time. Okay, so now we got random treasure spots, and we got our player location set up. So now it's just time for the main loop. So for int I equals 0, I is less than 10, I plus plus. And I kind of don't like the number 10 here. It doesn't mean anything. So I'm going to come up here and say const int max steps is equal to 10. And now we've got English here instead of a magic number. Max loops, max steps. And I don't like this 5 here either, because what if we change the size of this later on? So we'll just set the size of this to be 5, and we'll do this, and we'll do this. And now, what's really nice is that if we change the size of the field from 5 to 10 or to 100 or whatever, it will update automatically. You don't have to sit there and go through every location in your code where you have a 5 hard-coded and hope it means the size. It might not always. You can use 5 for other reasons too. So that's why constants are so important. Don't use any magic numbers ever, is my advice to you. 0 is fine, 1's sometimes okay. Anything else, no. Make a constant for it. Okay, so we got this. So the next step would be, I guess, doing the input. So we will say char c is equal to read. Please enter a direction. north, south, east, or west. Okay, and C is equal to 2 upper C, or I could wrap it around read, but I'm not going to do that because it'll introduce a subtle bug that doesn't matter. So now I read in a letter. It could be any character, and then I uppercaseify it, so I don't have to worry about lowercase n or uppercase n. Cool. So then I just handle the input. So if C is equal to capital N, then we'll do one thing, and let's see, Y will be increased. Can we do that? Else if C is equal to south, Y is decreased. Else if C is equal to west, X is decreased. Else if C is equal to east, X is increased. Else they typed in something bad, so we'll just quit. Okay. All right. So then let's just see out all the things. See out X is equal to X and Y is equal to Y, and let's just see how this goes. Okay, so north, 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 east, 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 west, west. Oh, no, it quit because I ran out of west, 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 right? Okay, so it works. So Q quit or whatever. All right, so we've got here the X and Y locations all set up. So the only remaining, we got 2 remaining things to do. One is to bounds check. So if we walk off the edge of the world, we should kill the player, I guess. So if X is less than 0 or X is greater than or equal to size, again, this is why we use a constant. So if we change the size of the world, it'll change down here and here and here, everywhere the size comes up. Or if Y is less than 0, or if Y is greater than or equal to, not 5, size, then see out, we're falling off the edge of the world, like Black Sabbath, and then we quit. Otherwise, cool. All right, so let's test that. So we go north, 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 and we fell off the edge of the world. East, 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 fell off the edge of the world. West, we're dead. South, we're dead. Okay, cool. All right, so we're doing bounds checking now. Cool. It'll stay within the 5x5 region we have defined as our map. The last thing we need to do is treasure. See if we got the treasure right. So if X is equal to treasure X and Y is equal to treasure Y, then see out, a winner is you. You win the game. Congratulations. Return 0. Okay. And then if we get to the end of the for loop and we've taken 10 steps without finding anything, then you lose. So see out, a loser is you. All right. And that's it. So 5 minutes. Okay. North, 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 east, 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 east. I found it. Yay. And that's why it's nice to print this debugging information, by the way. Because when if it's in a random place you don't know where it is, it's a lot harder to test your code. You know what I'm saying? East, found it. North, 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 east, east, east. There's actually one very subtle bug in here that a previous student pointed out, which is that if you start on 0 with the treasure on 0, 0, it's not going to find it. So I said that's a good point in the previous class, and just toss that up there, and yeah. So if it spawns randomly on 0, 0, then we will handle it. North, 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 east, 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 south, south, west. A loser is you. Okay, we took too many steps. Were you supposed to print out a game board? Nope. Nope. You could if you want, but no, have to. That's it. That's the game. 5 minutes of coding. And again. It's not to flex. It's to show you the direction that I took towards solving the problem, right? And at the end there, I could have either done the treasure winning first or the bounds checking first, Either in the previous class I did it the other way. It doesn't matter. Just check add one feature. Does falling off the edge of the world work? Check it. Check in every direction. Check that you don't have an off by one error. And then check for victory also. And so every time you add a new feature, like you can win, or you can lose, or you can go off the edge of the world, you add it, save it, compile it, run it, test it, add a new feature, save it, compile it, run it, test it. And then the overall breakdown of this, how I approach solving the problem, again, that's something that develops through experience and through watching experienced programmers solve it. So that's it for today. You've got your Mandarin assignment. You've got Hack the Mainframe if you didn't do it before. Hack the Mainframe is due on Monday. Zybooks is due next week, and Mandarin is due next Friday. Okay? So have a great weekend, and I shall see you all on Monday.